Hello, everyone. Hopefully you can hear and see us okay. We're just going to wait a minute or two for more people, give other people the opportunity to join. But whilst we wait, maybe people can share which companies they come from and where they're located. Hello to everyone who's joining. Thank you for joining. We're just waiting a minute or two for the participants to get up to the registered around about the registered level. So whilst we wait, if people could pop in the chat box where they are coming from, which company they represent, and yeah, we'll get started shortly. Hi, John. Rolls-Royce, small modular reactor. Lindaptor International in Bradford. Rupert, nice to see you from Whatcraft. Caterpillar in Peterborough. Emerson's in Manchester. Bull picture from north of Scotland. So we had about 100 people registered today, so we're just going to give it one more minute and then get going, I think. Hello, Roger. Hello, Ian. Okay, Kay, do you want to kick us off then?
Good afternoon, everyone. Welcome. It's a pleasure to be introducing this webinar today, and I'll be moderating this session as chair of the Energy, Environment and Sustainability Group. And we're proud to present this webinar to be introducing Christian as well, who will be going through this. For those not familiar with the group, we take on the big challenge of looking at how we help our profession in embedding sustainable practices, and beyond strategies and policies, what's really important that we also emphasize on is the practicalities of implementing these principles and answer the questions of how can we support engineers in being able to individually make positive impact as well. So this is why this webinar is very important in looking through Scope 3 emissions, and also, sorry, my screen's gone funny. 1 second. Apologies. Which is why this is quite an important webinar to look through Scope 3 emissions and also how we embed those considerations through product environment engineering. So without delaying us any further, I'd like to pass on to Christian, who's our speaker for this webinar.
Hello, and thank you, Kay. Yes, welcome. Good afternoon. I'm a chartered engineer and practitioner member of IMechE. I'm currently a contractor environmental engineer to Airbus helicopters. I've worked for a few defense and aerospace primes, doing some similar types of work. So I thought I'd share some of my thoughts and findings with yourselves. Okay, so the aim of this this webinar is to provide an overview of how we can reduce Scope 3 greenhouse gas emissions through product environmental engineering. We're going to give a brief overview of what Scope 3 emissions are, talk about some drivers, influences, requirements, legislation and regulations, brief talk about how we do environmental impact assessments. Going to talk about different ways of mitigating some of the identified impacts, and then touch on a couple other topics on recyclability and emerging technologies and how they relate to sustainability. So, what is Scope 3 emissions? So the Greenhouse Gas Protocol is an international standard which divides all emissions generated from individuals or organizations into three scopes. Scope 1 is direct emissions, so think fuel burnt in vehicles or fuel burnt in heating systems, directly by the company. Those are Scope 1 emissions. Scope 2 relates to energy bought in from somewhere else. So if your company doesn't generate its own electricity, it probably buys it from a utility provider, that would be considered Scope 2. Scope 3 is essentially everything else, includes upstream and downstream supply chains and customer uses, which is going to be the prime focus of today, but I'm also going to touch on some wider aspects of environmental engineering. So we start off with the first poll. Want to make it a bit interactive, so if you could launch the first poll, which are the biggest drivers for product environmental engineering? Hopefully that comes up on your screen. Yep. Okay, we're starting to get some results through now. We'll just run it for 30 seconds, 45 seconds, something like that. Okay, it looks like the numbers are more or less stabilizing. So there seems to be a majority, about 60%, consider policy the biggest drivers for product environmental engineering, followed by about 30% saying there's a financial benefit, and 8% saying there's non-financial benefits for that. Okay, thank you. If we can end the poll there, and I'll go back to just trying to close the poll myself. Right. Okay. So the next slide is we can talk about some of the drivers. So there's an overarching international drive for sustainability. Although in COP29 in November, the UN Secretary General was talking about, to hit our target of 1.5 degree temperature rise limit, we need to cut emissions by 9% every year, and by 2030 they need to be down 43% against 2019 levels, but they are still growing. So in amongst all that, there are a number of drivers for product environmental engineering. Some relate to policy, whether those are company, sector, international strategies, or legislation and regulation, things like non-financial disclosures, investor mandates. These all kind of grouped together as untermed policy drivers. There are some financial benefits to doing this type of activity, whether that's developing IPR that you can sell, and R&D, which you can sell for extra revenue streams. There may be some increases in efficiency, and typically there's cheaper insurance, credit, and tax as well. But there are also non-financial benefits. So these are demands that might come from investors, society, customers. If we focus on things like ensuring we recycle our materials, then when we recover the critical raw materials, then that can improve things like supply chain resilience. And then there might be sort of national initiatives around things like green jobs. Okay, so next slide is I've drawn a context diagram, so no doubt you will all be coming and representing different organizations that develop products and services. And within those organizations, there will be influences for implementing product environmental engineering. If we take a step out, as this is an IMechE webinar, IMechE is a British-based institute, does have overseas activities, but essentially the nearest influences to us are things like UK engineering sector, customers, government, investment society, but also things like British Standards Institute. If we take a step further out in terms of our levels of influence, we can start thinking about foreign industry, markets, governments, investment, and things like European standards bodies. And then the third and final level influence with thinking more on an international level, there might be some global strategic trends. There's organizations such as the UN or the IMF, that and ISO standards bodies that might influence how much product environmental engineering goes on in our products and services. So if we think about environmental management requirements, I've categorized a range of requirements into themes, and map them to whether they come from a legal certification or contractual basis. These ones on the screen at the moment represent those that relate to greenhouse gas emission reduction. So if there's a greenhouse gas, so let's take the first one, for example, there might be a certification or contractual requirement to reduce our greenhouse gas emissions. Obviously, that can help reduce scope 3. If we think about waste, if we've got there are a plethora of legal requirements around waste management. If we do that in a responsible way and legally compliant way, then that can help reduce not only the materials that we demand. If we can do things like recycling waste electronics, we can recover some valuable materials and therefore not spend more emissions extracting them from the ground. But also if there's designated ways of getting rid of our waste that doesn't involve things like burning, then that can reduce the emissions as well. Obviously, energy consumption. I guess I'm talking about energy efficiencies within products and services. If they can be managed closely, then that can help reduce emissions, consumption of energy, and therefore emissions generated. There might be some certification and contractual requirements to have an environmental management system or to conduct a life cycle assessment or analysis. And they can give you a wide picture about your product and service, whether that's cradle to cradle or cradle to grave. If you've got a better handle on where your environmental impacts lie across your product life cycle, then you can more easily target how to reduce them. There may be some contractual requirements to develop particularly sustainable technologies. And obviously there's a legislative compliance aspect to it, to everything we've talked about so far. And then a kind of new kid on the block is scarce materials. I know the EU were tabling a law around what to do with disposing of critical raw materials. Again, responsible disposal or recovery of scarce materials links into that kind of supply chain resilience, and therefore not relying on global supply chains, extractions and transportation, which can all contribute to reducing our emissions. Now, in product environmental engineering, there are other themes to consider as well, but these aren't necessarily that closely tied to scope 3 emissions, although they ought to be done anyway, especially when there's a legal requirement to do so. Now, if we move on to legislation and regulations, I've categorized legislation and regulations that I've dealt with into 12 categories. When I'm talking about, say, a recent project, I'm looking at 50 plus legislation and UK legislation and regulation that apply to the product. Of course, not all of them apply to reducing scope 3 emissions. These first three generally do. So if there's things like star energy ratings um, or energy efficiency regulations that need to be complied with, if there's uh, laws around waste management and materials consumption, these all contribute to reducing scope 3 emissions. We've already talked a bit about energy and waste. If I just allude a little bit more on the materials aspect, there's a little you might see there's a picture there of some fire hydrants. Some older designs of fire suppression systems use ozone depleting substances that obviously burns a hole in the ozone layer. We've tried to regulate those out, not completely, but there are special cases where they can still be used. But a typical replacement for those would be fluorinated gases. Fluorinated gases also have a high global warming potential. So if you can avoid those two, you can design those two aspects out of your system, those two materials out of your system, then you can potentially reduce your um, your scope 3 emissions in your product. Okay, now we're going to talk about environmental impact assessment. So when someone is conducting a life cycle analysis, they might go through this activity of trying to identify different activities their organization does, which has an impact on the environment. Once you've gone through the process of identifying all the different activities that might have an impact on the environment, you can apply a scoring mechanism using a severity and probability assessment. Now, once you've applied the severity and probability to that impact occurring, you can plot it on this excuse me, something similar to what you can see here in the picture, a risk matrix, and which helps you identify which are your higher priority impacts that ought to be considered for further mitigation. It's worth noting that when doing this activity, it's best to consider the entire life cycle of your product. Not always possible when you consider supply chain management, but certainly possible when you're considering the different operations that undergo in your organization. Then it's also important to note that when we're talking about this environmental impact assessment, we consider normal, abnormal, and emergency operating conditions. Okay, so poll 2. Which stage of the product life cycle can most scope 3 emissions be mitigated? Just give it another minute or so. So I've put up some different product life cycle stages where which might be considered for mitigating some of these impacts. Okay, so we're looking at roughly about half, saying sort of requirements stage, closely followed by the development stage, and then sort of dipping in and around the kind of test and integration, transport, and end of life. It's probably 10% or lower, saying that's when most mitigations can be implemented. Okay, yeah. Yeah, so the what people are saying is generally about half. You can say in the requirement stage, and then subsequently the development stage, etc., etc. That's great. Thank you. Okay, right. Oh, so the next, yeah, if we could end the poll there, thank you. Right, so this next stage, we can talk about the next few stages. We're going to talk about the different mitigations that we can implement. But first, worth noting that that diagram on the bottom left quite closely reflects what people thought. The opportunity to reduce your emissions throughout your product lifecycle occurs um, in the earlier stages of your life cycle. So either in conception or design. Once you fix your design, then you're generally constrained and committed to generating particular emissions as a result of manufacturing and using your equipment. So when we're talking about mitigations, we're first going to talk about some design considerations which can be used to reduce your emissions. So in the middle of the screen, we've got a typical product life cycle that you might come across. If we consider the requirements, setting good environmental requirements sets us up for a great opportunity to reduce emissions. That might be user visions or specific environmental system requirements. They might be something like using materials that minimize hazardous materials or a product that can be recycled or is recyclable when it reaches its end of life. Sorry, it might consider a product that can use recycled materials or is recyclable at its end of life. At the developmental stage, you can consider some low impact priorities, for example, low impact processes like CAD and CAM. You can think about trying to minimize your resource consumption, not only in the product design, but also in the activities that you use to develop the system. And you can try and minimize your emissions generated as a result. In the test and integration phase, when we're optimizing, trying to optimize our design, you might use test benches. Maybe there's opportunity to use low energy consumption on your test benches. If you use modular prototyping and additive manufacture for other prototypes, you can practice and develop particular modules and then swap them in and out and experiment to try and find the best solution for you. In the transportation phase, subcontractors, you might select subcontractors that are near to the customers. You can select environmentally friendly delivery methods, for example, sea and land as opposed to air transportation. Not always possible, but there might be some opportunity there. And eco-packaging, I mean, a good example of this is just wooden boxes. They can be used and reused numerous times and have low impact on the environment. And then you might select subcontractors that you have a net zero roadmap as well. So if we think about the use phase, space, weight, and power consumption, trying to minimize that is very much well established in the sort of developing a suitable product for the customer. But there's also things like building in performance monitoring and considering your maintenance operations as well. So the long supply chain that helps supports your product in service. You can think about your spares and repairs to keep your product in good use. And then when we think about end of life, if we do some life cycle tracking, both on the system and modules within the system, which are also if they're also designed to be removable, then when a particular module comes to its end of life, instead of scrapping the whole system and getting a new one, you can swap it in and out specific modules. If you use recyclable materials, then that obviously removes the need to consume more virgin materials on a subsequent design iteration. Try and use materials without or with few hazardous substances in them. That removes the need to manage use specific management techniques to dispose of them. And feedback's really important as well. I'm not talking about just in the design, although that is a piece of feedback that's important, but also in the process and the knowledge, and the commercial aspects, feeding that back into subsequent design iteration loops is essential to trying to decarbonize your products and services. So if we think about facilities, environmental impact mitigation, um, your facilities will have opportunities to reduce scope 3 emissions as well. That might be minimizing electricity and gas usage for your heating and offices. You can implement energy saving initiatives like um, sort of motion sensor lighting, waterless urinals. You might have some EV charge points on site. Environmental information, if your facilities is geared up to record environmental information, you can measure and record your scope 3 emission performance. The obvious one is utility metering, but also things like quantities of waste and quantities of material consumed, document storage, and trying to um, ensure that that information is available um, for your customer, including information that might come from your suppliers. Trying to obtain that information and making that transparent and easy to access is really, really important to understanding how you can reduce your scope 3 emissions. We've talked about waste management. There's responsible disposal of hazardous and non-hazardous materials, but also application specific as well. There are some waste electrical and battery recycling methods out there. If essentially if you can honor the waste hierarchy, which is shown there, then you're onto a good route to trying to reduce your emissions through lack of needing to obtain more materials and burn unwanted materials. And then your eco design as well. If your facilities uses white goods, power tools, tooling, selecting those that have good Energy Star ratings or energy efficiencies can help reduce the embedded emissions in the development of your products. Obviously, in product environmental engineering, there are other aspects to consider. Mainly around sort of pollution management. But like I said, and just sort of touching on these just to show you that it's not just um, emission. It's not just you don't have to be just emissions focused. Okay, so the next slide we're talking about software architectures. The overriding principle here is software is generally lines of code that need computation. If you can reduce the amount of lines of code, you reduce the amount of computational energy required, and therefore you reduce the amount of energy you consume. So if we take a typical product lifecycle again, when you're defining the scope of your software architecture, you might select different programming languages or operating systems that have different emissions related to them. In the architecture and design, you could have dedicated circuits rather than reprogrammable circuits, which could potentially reduce your emissions as well. And it's good to consider the use of low-powered hardware. So, for example, if you run an application on your phone or your smartphone or your tablet as opposed to a computer or laptop, then there's some opportunity to make some energy saving gains there as well. And the developmental phase, if we talk about optimization of your software, we're talking about trying to minimize the use of things like dead code, unused code, but also in the architecture, if you've got different software operations that require information from a library, and there's some commonality between two libraries, then can you combine them into one library, and therefore reduce the amount of code that has to be put through your software. In the test phase, you might consider your test instrumentation and automation strategy. So you might use a third party test method, or you can build it into your system as a kind of an internal test. It's worth looking at which of those is the most energy efficient. And then in the operation and maintenance stage, there's things like smart. You can, if you're smart with your cloud data management and your data mining, then that can provide you with opportunities to reduce effort and energy. When you're designing and locating your data centers, you might consider the build, HVAC, and power supplies. They can be selected in a way that reduce the the amount of energy required to operate them. And also performance monitoring is important as well. You know, if you track the performance of your applications over time, and you start seeing some performance dropping off, you can take some intervention, get that utilization rate back up, and therefore maximize the amount of useful use out of a given proportion of emissions. Now we're going to talk about recyclability. So I did an MSc thesis on system design for recyclability, identified 20 drivers for that. I have got this in a life cycle format, but it's a little bit complex. It was easier to present it like this. The idea being if you can adopt some or all of these principles, then you improve the ability to recycle your system and therefore reduce the amount of emissions required to manufacture and obtain the materials for new products and services. Talk about emerging technologies. So there are we've got things like topology optimization and generative design, which can reduce the amount of material you use in your design. A little image there showing a component which when it's run through these mechanisms can you can clearly see that there's a lot less material used. Additive manufacture can reduce the amount of material used in the manufacturing phase. Industry 4.0, Internet of Things, can promote things like lean manufacture, live key performance indicators, which can be easily tracked remotely rather than having individuals travel to or you know laboriously in some way time consuming to try and obtain useful full data. There's things like digital twins and predictive maintenance, which is good for health and usage monitoring and therefore promoting reduced downtime, therefore maximizing the amount of utility you're getting out of your product, rather than having a new system which has cost you a big carbon footprint which you're not getting any use out of. And then there's AI-driven analysis, which might be repair, availability, maintainability predictions, or material research. That's obviously a hot topic and has potential to make sustainability opportunities. Then the last one is lifecycle assessment technologies. There's a whole plethora of softwares out there which are available to companies to monitor and analyze their operations. Okay, so poll 3 then. So based on the different types of mitigation I've talked about there, which areas of emission mitigation will you be implementing the most of? So we've got product design, facilities, software, recyclability, or emerging technologies. So there's a big, it's looking, oh, it's changing. So the leaders are looking like product design and facilities management, followed, which is roughly 50-60%. We say we've got about 20-25% saying recyclability and emerging technologies, and 7% software. I guess that's probably accurate. I mean, we're a mechanical and we're the IMechE, so perhaps people don't get heavily involved in software, and there might be any small gains anyway. Um, but yeah, product design and facilities management seems to be coming out on top there. And I guess that's refreshing to see because the areas the projects I've worked on, facilities management is a very big area for these opportunities. Product design is something that has the huge potential, but historically I haven't seen that adopted as much as I would hope. But yeah, thank you for that. If we end the poll there. Okay. So in summary, Scope 3 emissions are typically the most challenging to abate. There are drivers from policy, financial, and non-financial sources. We've identified 16 themes of requirements across legal, certification, and contractual. There's 12 categories of legislation and regulation, potentially 50 plus legs and regs for one product. Impact assessment is not too dissimilar to risk management for those that have been involved in that type of thing. Mitigations are available within design, facilities, and software management. We've talked about recyclability and emerging technologies to provide sustainable options. So, if we round up here then, um, if you were hoping for some lots of case studies of these principles, I guess I have seen a number of them. Um, it, I've only got an hour to fit everything in. Um, there might be some commercial constraints and project specifics associated to that. However, there are if that is something you want to know more about, there is a 2-day course on product design for sustainability and circular economy. The QR code's there. There is an upcoming event in April that the IMechE is running, 3 events in one location, relating to decarbonisation of your industrial clusters and sort of power plants. And if you wanted to connect with me, feel free. The QR code for my LinkedIn profile is there. But yeah, I'd like to take any questions anyone might have.
Thank you so much, Christians. That was really insightful, and I think some questions are starting to come in. So please do, if you have any questions, please pop it in the chat. Really interesting to see the various opportunities that we have to consider our impact as well. Let's see what some of those questions are coming up. Can you say anything about storing data offline rather than in energy hungry data centers?
Yeah, I guess it depends on how much data. There are and there's a cost associated to that as well. If you want to keep control of your data, that's perfectly reasonable. I guess what I'm alluding to is that if you can access that remotely and you can store it in a say a native cloud, if that's a thing that exists. I'm sure I've seen products online for sort of a personal cloud drive, personal servers. Then there are opportunities for that. I guess it's important to consider like how much data you're storing, how you're going to maintain design and maintain your data storage. Is it in the office and therefore needs lots of cooling and therefore more hungry on your air conditioning, or can you install a kind of external facility that as naturally air cooling? Can you put it under shade? That sort of thing. Yeah, hopefully that gives some idea as to some considerations when dealing with sort of native data.
What I thought was really interesting as well was seeing what people thought about where they thought across the life cycle stage they can mitigate scope 3 most, and there was quite a close split between requirements and development design, but also some on the transport. It's quite a reflections of potentially a reflection of people's role and also the type of product that they're creating, isn't it? And the importance of looking at product environment assessment to know where's our impact and therefore where to focus our mitigations. Um, any thoughts that you like to expand on those areas?
Yeah, so uh, I guess the UK is service sector heavy, and so it's easy to think, well, I can design a product, but in the manufacturing phase, developmental manufacturing phases, are we constrained? Um, but if you take a whole sort of life cycle and assessment approach, even if you're not in control of a particular product life cycle phase, if you outsource that, for example, um, there are still opportunities at every stage of the life cycle to implement sort of energy well, scope 3 emission savings. Um, for my current company, where I'm working at Airbus Helicopters, they don't manufacture the aircraft themselves. So that's, although I can try and obtain environmental data to pass on to our customers, we can look at, how can we implement the kind of wraparound facilities management slash support and service aspects to make sure that we're minimizing emissions that way. But yeah, it's refreshing to think that people are empowered to make some scope 3 emission savings in the product life cycle. I think facilities is is a well-trodden area. I've seen lots of content around EV, solar voltaic, PV, solar PV panels, green transport initiatives. That's green energy tariffs. That's almost like the easy stuff to tick off. It's the kind of embedded stuff which I see that is typically most difficult to do. But it sounds like people feel empowered to do that.
Yeah, thanks very much, Christian. It's sort of a very interesting question on what you think. How important do you think EPDs are? How significant and relevant are EPDs in your opinion?
EPDs, sorry,
Those are environmental product declarations. Is that right, Alistair? Is that what you're asking?
so sort of declarations about how much I haven't come across these. So they're like, if I'm understanding correctly, they're declarations of what your environmental impact is.
Yeah, they're sort of related to environment impact assessment, aren't they, Alistair? And builds upon EIAs, and then the EPDs are what's reported in terms of the environmental impact of products.
Yeah, okay. So I I think it's so yes, so every product would have an EPT, yeah. I guess it's sector specific. So I've worked a lot in defense. We call it environmental case, and they are absolutely significant, especially for the UK. The UK government require um, certain government contracts to have an environmental case or environmental. Sounds like very similar to an EPD. Um, it's important to do a full life cycle analysis to understand what your impacts are, and for me the important bit is like, and what can we do about those impacts? The identifying and categorizing and prioritizing what the impacts are is only half the story. Um, there may be a kind of if you set up your systems to track the environmental performance of your products and services over time, um, then that sets you up for sort of trending over times or you over design iterations. So you can sort of say do like an initial baseline and say, well, these are our impacts which we've identified, and these are our priorities, and we've got some ideas about how we can mitigate those. And then if you are tracking, you've got sufficient ways of tracking that information, you can, 2, 3, 4 years down the line, you can say, and looking backwards, this is what we've implemented, and these are sort of new initiatives coming up, or these are barriers that are particularly tricky. Um, I think an EPD or environmental case is a great way of articulating and reporting on everything that involves.
Thank you very much, Christian. I think that's quite clear. Um, there was also another question on whether there was any recommendations on, or if there are any widely available tools that you would recommend for designers to reduce Scope 2 emissions during product design.
Tools for reducing scope 2 emissions. I'm trying to think what we mean by tools. I guess there's different ways. Oh, is it meant scope 3? Okay.
Go through. Okay.
What are the widely available tools that you recommend for designers to reduce scope 3 emissions in product design? Um, well, I've seen a whole range over time. You can speak to consultants and you can look for climate tech and there's a loads of software um, startups that and kind of big OEM software firms that provide opportunity for this. I've seen some software that you can type in a sort of a carbon tax and do some modeling around your corporate finances. Um, I've seen tools for identifying and tracking and highlighting changes to legislation and regulation. Um, but I guess it can be a bit application specific in terms of what your project is, what your company is. It's it require it. There's a you got to go with a set of data requirements really, and making sure your operations are set up to provide the data, and then you can kind of embark on researching the different options out there and trying to focus in on something that is best for your application.
Thanks for that, Christian. I think that's it's quite interesting question around how we. Hold on a second. If there's an effective way of developing business case for Scope 3 emissions reduction, whilst also maintaining business and product competitiveness. Do you have any examples that you could share?
Um, yeah, I do. Effective way of developing the business case. So an easy answer to that is if your customer has or your investor is looking for particular um, reductions in your corporate emissions, then um, that's there's a clear mandate as to and then you've got like non-financial disclosures and ESG ratings. Like there's a clear mandate as to why it's worth trying to reduce your emissions in general. Um, but outside of those kind of um, mandates, if we're thinking at a sort of more granular level, um, an example I worked on was a kind of autonomous helicopter, essentially. Um, and when you compare the emissions of that versus a manned helicopter that would do the same operations, there was like a 95% savings on emissions. And that was like actual data um, from looking at like fuel burn per hour. Um, there's it was an easy comparison there. Um, there's also things like our innovation, being leaders in innovative technologies, which is a bit more difficult to measure. You'd have to do like a benefits management plan to kind of determine that. But you gotta have at least one person, the person either commit writing the business case or the person who's asked for the business case to be committed to at least exploring opportunities to maximize your emission savings.
Thanks, Christian.
Sorry about
Yeah, that
that.
was very helpful. So thank you. Thanks for that. Yeah, it's helping people to see also the short, long-term benefits as well of Scope 3. We do have another question for you around e-fuels. So specifically, what are your thoughts on e-fuels for power generations or transport which emit greenhouse gases but are overall carbon negative, such as ethanol?
Um, e-fuels for power generation and transport. Yeah, so it's important to delineate between biofuels and e-fuels. Biofuels is, waste, um, agricultural or chemicals that can be combusted, whereas e-fuels is um, fuels generated from synthesizing CO2 from the atmosphere and water. Um, the method in which the energy required to do that is quite hungry. Um, I think it's important to consider how that energy is generated. So if you're using green hydrogen, good. If you're using renewables, good. If you're burning fossil fuels to generate your e-fuels, not so good. Um, but it goes a little bit beyond that as well, because if a Saudi Arabian plant sets up to generate these e-fuels and then rolls it out to loads of aviation aviation airliners around the world, you're on the right track, but if you're having to fly the fuel to these locations, then when you do your life cycle analysis, although you're making some savings in your production of the fuel, which can be potentially substantial, you gotta make sure you're not completely offsetting it by transporting it around. I think there's a conversation around infrastructure as well. If you who's got the money, who's willing to put the money down to build these sustainable aviation fuel or e-fuel sites. Um, if there's something just across the channel in Europe, then that that could potentially be quite useful, um, or indeed in the UK. But yeah, it's not always as simple as that. It depends on who's willing to foot the money in the first place.
Thanks very much for that, Christian. We've got one more question coming in. Do you have any estimate of the potential for reducing our industrial emissions towards the UK's targets by full implementation of Scope 3 emission reductions, and any comparison with Scope 1 and 2?
Um, Industrial emissions towards UK's targets by full implement. Um, so there are activities um, ongoing to try and decarbonize the industrial clusters and power generation. I should put the final slide up again. There's like that 3 day event is a great place for um, great place to potentially find out some figures for that. I haven't seen any figures myself. Um, I think scope 3 emissions tends to be a little bit kicked down the road. I think it's easier for the UK to say, right, we're going to focus on scope 1 and 2 emissions because we're building renewable energy supplies, and obviously you've got to build the infrastructure, and there's battery technologies and there's EV technologies, um, which all contribute to um, some of the emissions, but there is a lot of offshoring, and that is allowable in terms of the sort of the international treaties that have been signed. Um, so if you're offshoring your emissions, um, the UK government generally say, well, we can't really do anything about it then. Um, because we can't really intervene in the industrial strategies of overseas countries. But if you're developing a product and service in the UK and having it manufactured overseas, you could set some good, that kind of setting good vision and setting sustainable environmental management requirements or sustainability system requirements. If UK companies that design products and services set those requirements for their overseas suppliers, then there is opportunity to reduce the scope 3 emissions of their products and services. Um, yeah. Otherwise, it can be a little bit a case of, one company says, well, I can give you the utility usage of my facilities, but we buy in loads of parts from another company, and if that another company is in the UK and they're required to produce give an overview of their emissions as well, um, then that's all good. But yeah, once you start talking about international supply chains, then it gets a bit more tricky.
Thanks for that, Christian. Yeah, I think carbon leakage is quite a big issue. But do you have any um, sort of consideration in terms of how we can better engage with suppliers to sort of get their buy-in and being able to sort of support this?
Yeah, so I have seen some supplier initiatives, supplier management initiatives. Um, it's generally, I think generally there's existing contracts in place. Um, there's there's strategies I've seen where it's just engage with supply chains and explain to them that uh, there is a requirement to have sort of net zero roadmaps, both in terms of like the company um, who who are the customer in that customer supplier relationship, and in order to answer that, they need a sort of set of environmental data from their suppliers. It's not straightforward, but it just requires good negotiation, really, and uh, willingness from supply chains to sit down with their customer, or your the host um, product host company, and just have those conversations about how they can improve there's not going to be any silver bullet. It's not going to be solved overnight, um, as I think it is in general for climate change and reducing emissions in general. But any you got to sort out the details and the small make the small gains, which will aggregate up to the bigger gains.
Thank you so much for that, Christian. We're coming up to time. Are there any closing thoughts that you'd like to share with our audience before we close?
Yeah, I guess it's just a case of don't dismay. There is opportunity everywhere to reduce emissions. It doesn't have to be more expensive option. There are lots of existing technologies and processes in place, which might favor reducing emissions. Sometimes it's a case of just putting it into a perspective and generating the data which will enable you to make those claims. Um, Sometimes it requires, what I've seen a few times is that there's a lack of knowledge in organizations. So coming along to this type of thing, reaching out to companies to try and learn about what the opportunities are. There's lots of societal events all around the country. Yeah, there's plenty of opportunity to make some gains. Um, so gains in reducing emissions. So yeah, hopefully people have found this webinar as of benefit. If we could ask you to fill in the feedback form, then we know what was good, what was bad, and how we can improve. But yeah, I guess I'll leave it there.
Thank you very much, Christian, and thank you very much, everyone, for listening. Hope you found that useful, at least in being able to raise awareness and also start to understand the importance of understanding our impacts so that we can best identify opportunities to start reducing our environmental impacts. Thank you very much all. I hope you have a very nice day.
Great. Thank you.